Hey, it's Matt here with an interview question from Meta, formerly called Facebook. This question is about calculating the average session time of a group of users, and I'm going to show you how to solve it in Python. Let's get into it, but before that, don't forget to subscribe to our channel to stay up to date with the latest interview questions. This is a really interesting question that is frequently asked at Meta data science interviews. The title of this question is Users by Average Session Time, and we are being asked to calculate each user's average session time. It is said that a session is defined as a time difference between a page load and a page exit. For simplicity, we can assume that a user has only one session per day, and if there are multiple of the same events on that day, we should consider only the latest page load and the earliest page exit. This is a medium level question because while it's rather straightforward to get durations of individual sessions from the events, it is harder to identify valid sessions and then take an average from time differences. And before we start devising the solution, let me share with you the 3 steps general framework for solving data science problems that we're using a lot in our videos, but also in everyday lives as data scientists. The idea is to first understand the data, then formulate the approach by writing a few general steps that can lead us to a solution, and finally writing the code based on this high-level approach. Following this framework, the first step is to understand the data. At a typical interview, you won't see any actual data, only a schema like this with column names and data types. In this case, the situation is rather simple. We're only given one table or data frame because we're in Python called Facebook Web Log. It has 3 columns: user ID, timestamp, and action. And based on the explanation given in the question, we can guess that the 2 examples of the action property are page load and page exit. But we can't rule out that this field doesn't take any other values. Maybe we also track if a user scrolls up or down during their session, then other values in the action column could be scroll down or scroll up. The kind of values that we don't need to solve the question, but we still need to anticipate that they could be there. We can also see that the timestamp property is set date time. This is important because it determines what functions we can use to manipulate these values. All in all, we can deduce that each row in this dataset represents one action that a certain user performed at a certain point in time. Next, we can formulate the approach, or a few general steps that will follow when writing the code. And the first step could be to extract only these rows from the dataset that we'll actually need. In particular, we're interested in these rows where the action is either page load or page exit. And we're doing this because we're anticipating that there may be also other actions stored in this dataset. And in the next step, it would be wise to create a table with all the individual sessions. Remember that a session starts with a page load and ends with a page exit, so we could have 3 columns, one for user ID, then one with a timestamp of a page load action, and one with a timestamp of a page exit action. And we can do this by merging all these page load timestamps of one user with the page exit timestamps of the same user. But the problem with merging all these timestamps is that we'll end up with some sessions that are not real. And that's because if a user has multiple sessions, and we, when merging, consider all possible combinations of their page load and page exit actions, we inevitably have some rows where page load comes from one session and page exit comes from another session. So to detect and remove these cases, we need to add some conditions, and we can start by adding a condition that page exit should always happen after page load. That's logical, and this will cover one case. But what about a situation when page exit happens after page load, but only a few days after? Or if a user has several page load actions in a single day and only one page exit? The question actually gives us a hint here. If there are multiple of the same events on the day, we should only consider the latest page load and the earliest page exit. So aggregating the data while selecting the latest page load and the earliest page exit timestamps should cover both of these cases. But what should we aggregate the data by? If we only aggregate it by a user or a user ID, then we'll end up with only one session per user, and it won't necessarily be a valid one. But there is one more hint in the question that could help us here. It says that a user has only one session per day. And this means that each valid session can be uniquely identified by a user ID and date tuple. And so we can aggregate the results by user ID and date. But for this, we need to add a column with the date of each session. We have a timestamp, but it's not really a date. So we can extract the date from the page load timestamp. And this is a step that we need to perform before aggregating the data. At this point, we'll be left with the valid sessions of each user together with the respective page load and page exit timestamps. So from here, it's rather straightforward to get to the final solution. We can start by calculating the difference between the two timestamps, and this will be the duration of each session. But let's remember that we're interested in the average session duration of each user, and each user can have multiple sessions that happen on different days. To get the solution, we can aggregate the data again, this time only by a user ID, and get the average of durations belonging to each user. Now we can follow these steps to write the actual solution to this interview question using Python. And as you can see, I already imported some libraries that will come useful. Pandas is the popular Python library for manipulating datasets, and NumPy offers, among other things, mathematical functions and was specifically needed to take the average of session durations in the final step. But let's start with the first step, and the first step is to extract page load and page exit actions from the dataset. So I will actually create 2 copies of the original dataset and 1 per each of these 2 actions. And to get firstly the list of timestamps of page load actions only, I will use the pandas log property like this. So I will say that I'm creating a new table or a new copy of the original dataset. I will call it loads. And I will take this original dataset, Facebook web log, and use the log property allows us to select a portion of this original dataset in this case. And then I can specify some conditions. Firstly, which rows should be selected. So I can say that I only want to select these rows where the column action in the original dataset is equal to page load. And after this, I can also select which columns should be in the output, and we'll only actually need the user ID and the timestamp because the action column will always be page load, so it doesn't make sense to show it. And when I run this code, we'll see that we're only left with 2 columns, and these rows here are actually all the rows from the original dataset where the action was equal to page load. And I can then do this pretty much the same thing to also get the exits. This time the 2 things change. I will give it a different name. So I will call this new table exits, and it will pretty much be the same thing. The only thing that changes is this condition here. Now I want the values in the action column of the original dataset to be equal to page exit and not page load. And when I run this, again, only 2 columns are left and slightly different rows. These are actually all the rows from the original dataset where the action was page exit. And the next step is to identify possible sessions for each user, and I'm saying possible because we don't know yet if these will be valid sessions. I mentioned already that we can achieve it by merging the page loads and page exits for each user, and so what we'll be actually doing, we'll be merging this first table here, loads, with the second table, exits. And to do this, I can use the pandas merge function. So I create a new table. I'll call it sessions because each row will represent 1 session. And I'll use the pandas PD because that's how I imported it. Pandas merge function. I'll say that we should merge the loads, the first table here, with exits, the second table here. Then we need to define how. So you may remember from SQL that we have different types of joins, like there's left join, right join, inner join. So this is pretty much the same thing here. So we just define, let's leave it left for now and see what happens. And we also need to define on which column the data should be merged. So again, similar to SQL, we have this on keyword when we join the tables. Here it's the same. So we actually join it on the user ID, so that the sessions or the timestamps from 2 different users will not be merged together. And when we run this, we have 3 columns. There is a user ID and the timestamp of the page load action and the timestamp of the page exit timestamp. And we can right away see 2 issues here. First of all, we can see that a user 2 right here has a page load timestamp, but has no page exit timestamp. And there could be many reasons for this. This could simply be a mistake in the dataset, and we don't really know, but we still need to deal with it somehow. And the interview question doesn't really specify what to do in such a case, but since we have no page exit, it's pretty much impossible to calculate the duration of such a session. So I propose we skip this session, we just remove this row. And to avoid such situations altogether, we can just switch this left merge to an inner merge. And in this way, the latter will only return rows where both timestamps exist. So when we run it again, now this row when the value was missing actually disappears. And the second issue is that these names of the columns are a little bit confusing. Timestamp X and timestamp Y. And to make it clear which corresponds to page load and which to page exit actions, we can add one more parameter to our merge function. And this parameter will be suffixes. And this allows to replace these X and Y in the column names with other names. In this case, let's replace it with loads and with load and exit. And it's important that the order of these keywords actually corresponds to the order in which we're merging the tables. So now when we run it, we can see that titles of the columns got updated, and now it's clear that we're actually dealing with user sessions. But as you can see, not all of these sessions are real or possible, because we merged all possible page load timestamps with all possible page exit timestamps. So for example, this session right here, we have a session load that happens on 28th of April, but the session exit or the page exit happens 3 days earlier. So it's clearly not possible. Or we also have some sessions that, for example, last several days. So this is quite obviously not real, not possible, at least in the context of this question. We can also see that for some users, we have, for example, 2 different page load actions at 2 different times, but only 1 page exit from the same day. So there is also something wrong here. And this is why we have these next few steps here where we can filter the valid sessions. And the first thing to do is to ensure that the page exit actually happens after page load. And we can do this with a function like this. So this is how we write conditions in pandas. So we can say that this table sessions now should be equal to such a table sessions where the timestamp load column or the value in the timestamp load column of this table sessions should be always smaller or earlier than the value in a timestamp exit column, again, of the table sessions. And if we run this, we can see that we're left with a fewer rows this time, and each time the timestamp load or the page load actually happens before timestamp exit. But we still have some other issues, for example, these sessions that span over a few days or several sessions of the same user in a single day. These are clearly incorrect as well. So to remove them, we can follow the next steps. For example, we can start by adding a column with a date of a page load timestamp. And to do this, we just need to say that we want to add in this table sessions a new column. Let's call it date load, and this column will be equal pretty much the same to as the timestamp load, so as this column right here, but we will just copy this this value, but only the date and not the time value. So we want to extract from this value only the date. So I'm actually using this function dt.date, and this dt it means that this function is specifically applied to the date time values inside this timestamp load column. And if we see our table again, we can see that a new column appeared with always the date of this timestamp. And having done this, we can now use these user ID and date load pairs to uniquely identify each session. So if we have a situation that for the same user, there exist different sessions that happen on the same day, then we know that only one of these sessions will be valid, because the question tells us that each user has only one session per day. And the question also tells us that it will be always the shortest session. So to actually always select the shortest session, we can perform this next step or aggregate the data by user ID and date and select the latest page load and earliest page exit. So to aggregate the data in Python or in Pandas, I can use the group by function. So again, I'm applying it to the table that we're using, the sessions, and I want to, as I mentioned, aggregate by two different columns, both user ID and the date load. This is the new column that we created. And now after I say that I want to aggregate, I also need to define the aggregation function. And since we actually want to use two different aggregation functions at the same time, I will use the pandas function agg that allows us to define basically custom aggregation functions and apply them to aggregated data set. So here I will say that I want two different functions. First of all, to timestamp load, I want to apply max because I want to select the latest page load timestamp. And then for timestamp exit column, I want to apply a min function because I want to select minimum or earliest timestamp corresponding to a page exit action. And in the end, I will also add one more function called reset index. This is just a good practice basically to add this function whenever aggregating in Pandas, because without it, Pandas would consider the user ID and data load columns as indices, and we wouldn't have them displayed. But now, as I run this query, this code here, we can see that we still see all the columns that we had before, and we're left with only unique user ID and date combinations. And these are actually the 4 valid sessions that we have left. And now it's quite straightforward, and we can move on to calculating the duration of each session. Because what we will want to do for each session, each row is basically one session, we will want to take this page exit timestamp and subtract the page load timestamp from it. So to do it, I can create a new column again. I will call it duration, and it's quite straightforward. I'm just taking the column timestamp exit, then a minus sign, and subtracting the timestamp load column from it. And when we display the sessions table again, we can see that a new column appeared with the duration in seconds of each session, basically. So this is exactly what we wanted. And the final step is to aggregate, because we're interested to get not just durations, but an average duration for each user. So we want to, for user ID 0, we want to get the average of these two numbers. And for user ID 1, we want to get the average of these two numbers in this case. And on the first glance, we should be able to aggregate the data by the user ID column like this, similar to as we did before. So using a group by function and saying that we want to aggregate this time only by user ID and applying a min function to it. So taking the average and applying this specifically to the duration column. Unfortunately, this will not work. And that's because the min function only functions with numbers. And well, it may seem to us that the values here in the duration column are numeric, but for Python, they are actually of a different data type, and this data type is called time delta. It's a special type for storing specifically differences between two timestamps before two different times. And this data type enables us to do all sorts of things, for example, converting this duration to hours or even days very easily. But for us, it's not very useful because it's not that simple to take the average or mean value from it. And the way to solve this issue is to use the mean aggregation function, not from Pandas library, but from NumPy library, because it's a more advanced one and it actually supports taking average of time deltas. And to be able to use a custom aggregate function, again, we can use the agg or agg function from Pandas, and we say that we want to take the mean function from NumPy. This is np, how I imported NumPy in the first place. However, this also won't work just yet. And that's because by definition, the mean function from the NumPy package or the NumPy library must take the values that it should take the average from as a parameter. So it should be here within the parentheses. So how can we pass all the different durations of each user separately as a parameter? In other words, how can we take, for example, for first user, these two values and put them here inside the parentheses, and so it's also automated. And we can use the pandas lambda keyword, and normally lambda allows us to iterate through all the rows while applying some functions separately to each row. But in this case, it's a bit more tricky because we already passed the aggregation step, but before applying the aggregation functions. So this means that the lambda function will actually return all the durations of one user at once, and then all the duration of the next user at once, and so on and so on. So let me show you what happens if I just use lambda, if I just print the result of the lambda function without using any aggregation function. In this case, you can see that firstly it returns the two durations of the first user, and right after this, the two durations of sessions of the second user. This time they are converted to hours and minutes and seconds because, as I mentioned, these are time deltas. And this is exactly what we can use. So now this X is basically these durations, and durations, all of the durations of the same user at once. So we can actually use it as the parameter to this NumPy mean function, just like this. Again, because we're aggregating, I will add the reset index function like last time, and now we can see that we're only left with two rows, one per each user, and the second column here, duration, in fact contains the average session durations taken from all the sessions of this user, and this is the solution for this interview question. I hope you enjoyed this explanation and learning how to calculate average session durations using Python. As you saw, questions like this one have many edge cases that our solution simply needs to account for. When you practice solving interview questions, don't forget to stick to our framework for solving any data science problems. It will make your interviews, but also your life, much easier. Once again, you start by examining and understanding the data, you then formulate your approach, and finally, based on these two, you can write your code step by step. That's it from me today. If you'd like to see more videos like this one, check out our channel and our playlist with many more data science interview questions. Also, make sure to subscribe to our channel to stay up to date when we publish new content. Thanks everyone.